All right, we're picking up again in 11.4 with the binomial probability distribution formula. And we're going to start seeing with problem 4, for example, that the number of times we can be successful might be different. So here a coin is tossed 3 times. Find the probability of successfully getting at most 2 heads. So n is 3. X is at most 2 heads. So we have to kind of decipher what that means. At most 2 heads means we could have no heads in our 3 tosses, 1 or 2. So we have 3 different answers that X could take on. P is the probability that we see heads on any one toss. Well, that's 1/2. And Q is 1 minus P, or 1 minus 1/2, which is also 1/2. Well, this means that we'd have to use the binomial probability formula 3 times. We'd have to use it when X is 0, we'd have to use it when X is 1, and we'd have to use it when X is 2, and add all these decimals together. Now, another option that we learned back in 11.2 is this idea of not. So we could look at X prime. We could look at, well, what's X not allowed to be? Is it going to be less work? Well, the total number of times we're tossing the coin is 3, and X can be 0, 1, or 2 heads. So what is X not allowed to be? Well, we couldn't have 3 heads. That would be more than 2. So if you recall, we learned that P of X could be found by doing 1 minus P of X prime. And for me, this is less work because here I only have to use the binomial probability formula once and subtract my answer from 1. Here I'd have to use it 3 times and add these answers together. So I'm going to do 1 minus, now remember how it goes, it's NCX, so it's 3C3. Then it's P to the X power, so it's 1/2 to the, this time the X prime power, because that's what we're doing, so 3, times Q, which is 1/2, to the N minus X, which is 0. The reason why it's 0 is because, remember, these numbers right here should add to the total number of trials. So now, we only have to plug this all in our calculator 1 time rather than 3 times. So we get 1 minus 0.125, and we will end up with 0.875 as our answer. Now for some of these here, if it's pretty straightforward, I'm just going to show you the initial setup and the answer. And you'll have to try to use your calculator to get to that. So if we're going to treat dolphins with an antibiotic. 85% of all dolphins are cured from an ear infection. If 7 dolphins are treated, find the probability that exactly 5 are cured. So N is 7 because we have 7 dolphins. X is exactly 5, no other option. P is told to us, 0.85 or 85% likelihood of success. And Q is 1 minus 0.85, which is 0.15. Setting it up, it's 7C5, 0.85 to the 5th, 0.15 to the 2nd. Answer is 0.21. All right, a couple plans to have 4 children. Find the probability that they have at least 2 boys. So N is 4. X is at least 2 boys, so that gives us options here. We have to think about what that means. At least 2 boys means 2 or 3 or 4 boys. So X gets to take on 3 different options. P, it says boys and girls are equally likely to happen, so the probability of having a boy is 1/2. Q is 1 minus 1/2 and also 1/2. Now, if we think about X prime in this instance, if we think about what would not be at least 2 boys, we would see that what's not going to satisfy at least 2 boys would be 0 or 1 boy. So if I did it straightforward directly to find x, I'd have to use the formula 3 times. If I wanted to figure out what didn't work, I'd have to use it twice, but remember, then you subtract from 1. So I'm just going to do it directly. So I'm going to use the formula 3 times. So I'm going to say 4c2. I'm going to start with x of 2. I'm going to do 1/2 to the second, 1/2 to the second, because these need to add to 4, plus, remember this is an OR, so we're adding on the next possibility. So 4c3, 1/2 to the third, 1/2 to the first, plus 4c4, 1/2 to the fourth, 1/2 to the 0. You're going to compute each one separately, so 0.375 plus 0.25 plus 0.0625. We're going to add that to 0.6875. All right. We're going to look at Babe Ruth's batting average. We're going to say that he is going to be in a series where he's going to bat 12 times. We want to know what's the probability that he will get 4 through 6 hits inclusively. That means 4, 5, or 6. So n is 12, x is 4, or 5, or 6 hits. P is the likelihood that he hits the ball when he goes up to bat. Well, that's his batting average, 0.342. Q is 1 minus 0.342, so 0.658. There's really no workaround here. We have to use the formula 3 times. So we get 12C4.342 to the 4th, 0.658 to the 8th, because we want these numbers to add to 12, plus 12C5 times 0.342 to the 5th times 0.658 to the 7th. Notice I have to use the decimal in its entirety here. I'm not allowed to round it, and I'm not allowed to shorten it. Plus 12C6, 0.342 to the 6th, 0.658 to the 6th. You're going to compute each one, so you get 0.24 plus 0.198 plus 0.12, and adding all of that together, you get 0.558. The next one is 65% of all orange trees will survive a hard frost. What is the probability that at most half of the group of 6 trees will survive such a frost? So n is how many trees we have to look at, which is 6. X is at most half, which, remember, that's options. That means 0 or 1 or 2 or 3, because 3 is up to half, of the trees will survive such a hard frost. P is 0.65, because they tell you 65%, and Q is 1 minus 0.65, or 0.35. Well, X prime, is it any shorter? X prime would be what does not satisfy at most half. Well, that would be more than half. So that would be 4 or 5 or 6. It's really your choice this time. Do you use the binomial probability formula 4 times directly and add it all, like we did up here? Or do you find these 3 with the binomial probability formula, add it, and subtract from 1? It's really your call. I'm going to let you decide on that. If you do this work, you should end up with an answer of 0.353. Last one, very short and sweet. In a certain state, it has been shown that only 50% of the high school graduates who are capable of college work actually enroll in colleges. Find the probability that among 9 capable high school graduates, in this state, none enroll in college. So N is the total number of students they mentioned, 9. X is how many they want. Find the probability that among 9 capable high school graduates in the state, none enroll in college, so 0. P is 50%, and Q is 1 minus 0.5, so also 0.5. Plain and simple, 9C0, 0.5 to the 0 power, 0.5 to the 9th power. Answer is 0.002.